Good day everyone. We are Team Satyanetra and our team ID is SIH 25035. Today we are here to give a presentation on our problem statement sentiment analysis of comments received through E-Consultation module. So let us proceed. The challenges we addressing is when ministries and organizations invite public feedback, they receive hundreds or thousands of comments in multiple languages. Reviewing them manually takes weeks and important feedback is often overlooked. Our project aims to solve this problem by building an end-to-end pipeline that automates data collection, data cleaning, data translation, and then moves on to a combined sentiment analysis and visualization of the entire combined data. Our technical approach has two major segments, one for showcasing the N8N workflow and then the AI pipeline showcasing of the model integrated into the project. Let us move on to the first phase.
Now, let me show you how our N8N workflow automatically fetches and processes public comments. We start with my MyGov website as an example because it's publicly accessible while MCA requires restricted access. The workflow begins with the trigger node. Once executed, an HTTP request fetches all the comments from the website. It grabs the entire web page data so we can work with it further. Next, the workflow extracts only the comment section from the web page, removing all unnecessary HTML and formatting. This gives us clean, readable text containing the author name, comment, date, and any attached files. The clean comments are organized into a table and stored into a Google Sheet. This makes it easy to review the raw comments and keeps everything structured for further analysis. After storing the raw data, the workflow sends each comment to the LLM for categorization and sentiment labeling like positive, negative, and neutral. To handle thousands of comments efficiently, we process them in batches of 50 at a time. Finally, the label comments are saved into a separate Google Sheet ready for dashboard reports and further visualization. So essentially, the workflow automates everything from fetching raw comments, cleaning, labeling, storing results. It's faster, scalable, and ensures every comment is captured accurately without manual effect. Here, I show you the Google Sheet. Here, you can see the total comments that we have fetched from the government website.
Moving on to the second phase, here's when the complexity of the dataset comes into play. The comments we worked with were very unclean, highly inconsistent, and contained multiple spelling errors, code switching between English to Hindi, and multiple duplicate entries. A significant amount of reprocessing was required, which included tokenization, stop word removal, normalization, language detection, which caused delays but was essential for ensuring reliable results. Although the dataset was very unclean, we created a separate dataset of around 200 plus comments upon which we cleaned and labeled them out according to their respective sentiments as you can see below. Now, let's move on to the model training section. Since there was a significant number of mixed up comments, we created and utilized a dual model approach. Here, as you can see, a translation model to convert comments written in Indian languages into English has been utilized. The dataset is mounted onto the Google Drive itself. We cleaned the text, tokenized them, and converted them into English beforehand. As we move down, you can clearly see a sentiment analysis model trained to classify feedbacks based on three segments: positive, negative, and neutral. This combined pipeline ensures that multilingual feedback is standardized, analyzed accurately, and despite the noisy dataset, our current model shows satisfactory accuracy and we continue to fine tune it for better performance. Together, these two systems ensure that every comment, regardless of language or length, is captured, processed, and converted into actionable insights. Our solution is both feasible and viable, supported by strong technical foundation, market demand, and adoption potential. Let us dive into the feasibility section now. Built with Next.js, React, Flask APIs, PostgreSQL, multilingual transformers, and N8N, our stack ensures scalability and modern performance. The system is modular with independent data pipelines AI modules, APIs, and dashboards, making it easier to update and extend. There is a clear demand from the government and regulatory bodies for automated comment analysis, as existing manual reviews are slow and resource heavy. Our platform delivers efficiency gains of 60 to 70%, reducing consultation review cycles drastically, and scales to handle thousands of comments with potential adoption across ministries and states. With integration into MyGov and MCA portals, it can reach millions of users nationwide. Whilst taking into consideration of the feasibility of this project, there are some challenges to it as well. Like, for example, code mixing and sarcasm-based comments that reduces accuracy, scalability stress during peak loads, model drift requiring retraining when policies or language changes, and continued human dependence for annotation and correction. Despite these challenges, our solution can automate analysis of draft law feedback, detect sentiment and categorize inputs at scale, track trends and emerging issues over time, and generate actionable dashboards and reports for policymakers. By taking into account a more business based approach, if done right, this project will not only be able to scale small comment section feedbacks but can also move on to generate a good working model which would be capable of cutting review time by 60 to 70%, handle 10,000 plus comments per consultation, create a structured data set from millions of feedback entries, and can speed policy decision making from weeks down to days. Go. Moving on to the impacts and benefits section, we performed a research and found the impacts and benefits of this project. Within the benefits part, we can conclude the following points. It cuts review cycles by 60 to 70%, reducing consultation time from weeks to days, analyzes 90 plus bilingual feedback in both Hindi and English, minimizing bias, achieves 85% sentiment and accuracy with multilingual transformers plus human in loop retraining, records 95% of comments, boosting transparency and citizen confidence, provides structured AI powered insight to policymakers, enabling faster evidence based decisions. Now, on to the impact section. It improves participation by 20 to 30%, ensuring citizen voices are heard, and for technical impact, it replaces fragmented manual reviews with an automated, scalable, multilingual system. All right, now that we are done with the overview of the problem statement, let us move on to the showcase of this project. Moving on to the impacts and benefits section, we performed a research and found the impacts and benefits of this project. Within the benefits part, we can conclude the following points. It cuts review cycles by 60 to 70%, reducing consultation time from weeks to days, analyzes 90 plus bilingual feedback in both Hindi and English, minimizing bias, achieves 85% sentiment and accuracy with multilingual transformers plus human in loop retraining, records 95% of comments, boosting transparency and citizen confidence, provides structured AI powered insight to policymakers, enabling faster evidence based decisions. Now, on to the impact section. It improves participation by 20 to 30%, ensuring citizen voices are heard, and for technical impact, it replaces fragmented manual reviews with an automated, scalable, multilingual system. As we are moving on to the ending of this presentation, I would like to list out the references we used, like platforms such as Qualtrics, SurveyMonkey, etc., and variety of already available materials like research papers and models on the internet for taking a reference for this project. Now that we are done with the overview of this problem statement, let us move on to the showcase of this prototype.
That's our AI powered platform for analyzing citizen feedback. From the homepage, click Get Started. For this demo, we will focus on MyGov. After selecting a platform, click on Continue to Input button to reach the Input section. You can analyze feedback using URL, keywords, or hashtags. Here, we input the post URL and select a 3-month time frame. We pick the deep analysis model for the detailed insight. Clicking Start Analyzing button. The results show up on the dashboard, giving an overview of total comments, average sentiment, and top emotions like trust. You can explore different sections like overview, voice, interpretation, storyline, trajectory, alignment, meta, methods, and exports to see the data from multiple angles. Interpretation tab highlights sentiment trends, frequent topics, and any misinterpretation. Storyline we cluster key narratives like economic recovery, healthcare reform, climate action, showing trends, sentiment, and sample comments for context. Trajectory section changes in sentiment over time and predicts trend for the next 6 months. Alignment compares narratives with national vision pillars like economic growth or social welfare, helping decision makers see gaps and areas of focus. Meta tab shows rising or falling topics, platform comparisons, and international benchmarks. In export, insights can be downloaded as CSV, PDF, or dashboards snapshot, all anonymized and secure for 30 days. In short, Satyanetra turns raw citizen feedback from platforms like MCA and MyGov into actionable insight. It tracks sentiment, clusters, narratives, and aligns feedback with policy goals, making public opinion easy to understand and action on.